navigation is hard. Now, imagine trying to navigate as a robot. How would you even start going about this? Today we'll be looking at how robots navigate known and unknown environments. From your robot vacuum cleaner to NASA's Mars rover, Perseverance, we'll be exploring different algorithms to navigate areas and how AI is used in all this. To start, we will be looking at something called a road map. This is where we represent a known area as a graph, then pre-compute a map, the road map, so that if we stay in the roads, we will be safe from all obstacles. So, how will we go about doing this? One way we can find safe routes is to plan paths along lines collecting the vertices or corners of any obstacles. This is called a visibility graph. So, how do we go about finding such a graph? One way is using something called a sweep algorithm. Suppose we have some obstacles, a starting point and a goal we want to reach. We first identify all corners of all shapes. Next, we go along and connect any point we can reach without encountering an obstacle. We repeat this for each point, eventually finding a safe path to our goal. This is great, but has one big issue. When moving, our robots may scrape corners, which is not ideal. Another idea is to keep the robot away from obstacles by finding points equidistant, perfectly in the middle of obstacles. For example, if we want to find safe paths to avoid these objects, we'll plan a route which is perfectly at the midpoint between any obstacles and boundaries. This is great for our robot Hoover, but what if we don't have a map to start with, like our robot in Mars? How will Perseverance find its way around? When trekking through the terrain in search of signs of life, the rover uses video footage to map the Martian surface, avoiding rocks and other hazards. Using two distinct cameras allows the robot system to measure perspective, and a system called visual odometry allows Perseverance to keep track of how far it has moved, comparing this with the expected distance travelled. The terrain is then classified using AI to create an approximate map of Perseverance's surroundings. Once this has been completed, we can apply the search algorithms looked at before to find a safe route around Mars. We have looked at only a few examples of robot navigation, but there are so many more. From robots designed to traverse tight spaces such as mines and pipes in order to carry out safe maintenance, to self-driving cars and drones. So next time you are struggling to decipher a map, take a moment to appreciate how robots find their way around.